This is the United States Energy Association Power Sector Podcast. I'm your host, Herman K. Trabish, covered the power sector since 2006, and I currently report for Utility Dive. My guest today is Stephen Hendrickson, Head of Market Analysis for the Department of Energy, or DOE, Office of Technology Transitions. Stephen has worked on policy analysis at DOE for over a decade and is currently helping lead the Biden administration's work to identify and support public-private investments that will transform clean energy technology innovations in long-duration storage from concept to commercial production. In this USEA podcast, we're going to talk about DOE's liftoff paper for long-duration energy storage, or LDES technologies, and recent progress in moving them to market. The liftoff paper is a detailed analysis of the commercialization opportunities for LDES technologies with capacities longer than the 4 hours to 8 hours provided by today's batteries. Stephen, could you please begin by briefly identifying the various types of energy storage, and not just batteries, that last longer than 8 hours? And why will they be needed as traditional but emissions generating electricity sources are retired?
Certainly. And first of all, thanks for having me. Happy to be here. It's definitely an exciting time at the Department of Energy, and always pleased to talk about long duration energy storage. The report that we're discussing can be accessed at liftoff.energy.gov if any of your listeners care to dive in further. To your question about the types of technologies we looked at for this report, really fall into three big buckets: mechanical, thermal, and electrochemical. In the mechanical space, that includes traditional pumped hydro, novel pumped hydro, gravity-based solutions, compressed air storage, liquid air, and liquid CO2. Within thermal, we're looking at sensible heat, like molten salts, latent heat, and thermochemical heat. And finally, in electrochemical, that includes aqueous flow batteries, metal anode batteries, and other hybrid flow battery technologies.
And why are they going to be needed? What's we're going through an energy transition, emissions generating electricity sources are being retired. What makes all those different types of technologies so important?
Yeah, so I think we really see sort of three big categories of opportunities, challenges that long duration energy storage can address. The first is enabling high renewable development and enhancing the resilience of the grid in a high renewable scenario. The second is to reduce the need for new natural gas capacity in the future. And the third is to diversify the domestic energy storage supply chain. So each one of these technologies, has its own supply chain, own inputs, and so that allows diversification. Often, many of these are using more inputs that are used for other industry sectors, so they can help diversify the energy system supply chain.
Right. And I'm really glad you mentioned the website where that liftoff paper can be seen, because you covered an enormous amount of ground when you mentioned the different kinds of storage. And they're all so interesting, from pumped hydro storage, which has been around for, I think, decades, to these new kinds of gravity concepts, and of course the big category of battery technologies. But DOE's liftoff paper focuses on inter-day storage, which is 10 hours to 36 hours of storage, and multi-day storage, which is 36 hours to 160 hours or more. And technologies in those categories could deliver 460 gigawatts of long duration storage and save electricity customers, I think, as much as $20 billion per year by 2050, according to the paper. But getting there, the paper reported, will require significant action by public and private players in three key areas. What's needed in those areas, and why is it needed?
Yeah, you're right. And we identified sort of two sort of market segments that, just to reiterate kind of what you were saying, the first being that interday 10 hour to 36 hour, which is really load shifting across the day. And the second being the multi-day 36 hours to 160 hours, which is about a week, which is more of a resilience application. And depending on the characteristics of particular technology, they may be best kind of positioned to work in a particular part of that those market segments. But as you highlight, really we identified three key activities that we think require further investment and engagement across the energy sector with stakeholders across the energy system. The first being continued technology cost reductions and performance improvements. So somewhere along the lines of a 45 to 55% reduction in capital costs and a 7 to 15% round trip efficiency improvement from today. And we have, at the Department of Energy, the Office of Electricity, the Energy Efficiency and Renewable Energy Office, other places where we're doing a lot of research and development activities that are specifically focused on those kind of activities, on those kind of improvements. Second, we need market and regulatory evolution to ensure that long duration energy storage systems are compensated for the value they provide to the system. So as you're bringing down the cost and improving performance, you need revenue streams for those projects so that they become economically bankable. And so there we're looking at something along the lines of a $75 per kilowatt year market compensation for long duration energy storage services. In addition, you have things like at the state level, longer integrated resource planning time horizons, LDES procurement carve-outs, other things that can be done at the state level to support those projects being developed, as well as at the wholesale market, the ISO level, where you could see expanded capacity markets or resource adequacy markets to compensate the same kind of system. And third is sort of in parallel, as we're continuing to build out renewables and you see more solar and wind coming on the system, we need to get developing the flexible and rapid supply chain development for these technologies so that as the need on the system for LDES increases, we already have the pieces in place to be able to build those products and get them into the marketplace as quickly as possible. So we really focus on sort of those three sets of activities all kind of occurring at this in parallel to get where we need to go.
Interesting. Two of those areas, but I should mention for my viewers, LDES is LDES or long duration energy storage. I don't want to get anybody to feel lost. But two of those three areas that you just described are sort of up to the private sector. They can be supported by DOE and federal policy and state policy, but the third one is regulatory. And I've seen lots of exciting movement, but U.S.'s electricity system is regulated by state. Is that the one that you find most challenging, or do you find it challenging?
That's a good question. So first off, I completely agree with your point that, we like to say that the clean energy transition will be private sector led and government enabled. So I think that's in line with the spirit of the liftoff reports, which is really developing a shared fact base between government and policymakers and the private sector. So we all have a shared understanding of kind of what the state of play is. And to your point, I think, as maybe many of your listeners appreciate, there are so many stakeholders across the energy system, the electricity system in particular, at the federal, state, local, regional level. I think one thing that maybe isn't fully appreciated sometimes is the amount of work, say, the Department of Energy does in developing tools to support those decision makers and understanding how to model out assets or see kind of how a particular asset will operate on the system. So we do a lot of work in that space, and I think that's really important. And then it is a lot of ongoing stakeholder engagement across those jurisdictions to make sure people have the sort of information and analysis to be able to make informed decisions about what are the best paths forward for their system to ensure, reliability, safety, cost effectiveness, and, low carbon.
Right. And it's just going to have to be a movement across all the spaces that you just described. DOE right now is also working to develop carbon capture technologies that could transform fossil fuel generation into clean energy. If that is proven viable and cost effective, both LDES and carbon capture could enable high renewables penetration and protect reliability. So what are the advantages of LDES over carbon capture? Or as the paper puts it, what are the leading and lagging indicators important to long duration storage's market success?
So I think that that ties back to your previous question, which is I think from the DOE perspective, we are just trying to put options into the marketplace so that private sector actors have a range of tools available to solve whatever problems they see or pursue whichever sort of economic path they think makes the most sense. And so for us, it's about developing these long duration energy storage technologies, carbon capture technologies, other grid technologies to really enable that optionality. Um, and to the second part, yes, there's a range of indicators, both leading and lagging, that we track and that we think really help to understand kind of what the state of play is in the marketplace. And then ideally that is a feedback loop both to government decision makers as well as investors, entrepreneurs, other people in the system to understand kind of where are things today. Things are evolving very quickly, and how are very specific technologies maturing, where are we seeing deployment, et cetera. So on the leading indicator side, we suggested a $1,000 per kilowatt capex target for intraday long duration energy storage and a $1,700 per kilowatt capex for multi-day technologies, and somewhere about a 70% intraday round trip efficiency and a 50% round trip efficiency for multi-day week LDES technologies. And then also looking for just a wide range of actors really engaging in the space. We'd like to see a number of different technology companies, getting their technology de-risked and demonstrated in the marketplace, again, to give the marketplace as many options as possible, and also appreciating that the right solution for one context may be very different than the right solution for another context. So just tracking that investment and the number of actors that are developing technology and able to deploy and demonstrate in the marketplace is important. And also looking for that, as I mentioned earlier, that $75 per kilowatt year market compensation for assets is a way to show that there is that revenue stream available to LDES projects. And then on the lagging indicator side, we're looking at something like 6 to 15 gigawatts of deployed LDES capacity by 2030, and something in the order of $10 to $25 billion in private sector capital mobilized for long duration energy storage projects. And kind of the tie into that supply chain piece that I highlighted earlier is somewhere around 3 gigawatts of domestic manufacturing capacity so that the industry is well positioned to scale up as demand increases.
Um, those numbers all represent important mileposts. And I would like to ask you something about how close we are to those indicators, but that's a fairly complicated question, and I know you could answer it because you have a numbers oriented analysis at your fingertips. But beyond the pure numbers, the liftoff paper describes a wide range of ways that the potential of LDES technologies could be demonstrated. So instead of just saying what the numbers mean and how close we are to them, what LDES projects have you seen since releasing the liftoff paper that are progressing toward those indicators and toward commercialization? And what technologies are emerging that have won public or private funding and support that will move them into demonstration and commercialization stages?
Yes, so last fall, the DOE's Office of Clean Energy Demonstrations, or OSED, is what to call it, announced 15 projects selected for award negotiations to advance long duration energy storage technologies, and this will increase the availability and affordability of clean, reliable energy across the country. That announcement includes about up to $325 million for 15 projects selected for award negotiation. 9 of those projects are part of the LDES demonstration funding announcement, and 6 of those projects result from lab calls working closely with DOE's 17 national labs. And then together that represents the active participation of 17 states and one tribal nation. So you're seeing a lot of activity across the country. I think it represents a diverse set of technologies, regions, geographies, use cases, market participants, a lot, whether it's on the investor-owned utility side, cooperatives, local communities, et cetera. These projects help us support and protect vulnerable communities by providing reliable sources of electricity when and where it's needed most, particularly following disruptions to the grid following extreme weather events or natural disasters. And just to give you just a couple examples, one of the projects aims to provide backup power for a children's hospital in a disadvantaged community. And another provides innovative storage solutions for remote communities in Alaska. So there's a lot of direct funding coming from the federal government to support those demonstration projects. And then I think in parallel, we're also seeing a lot of activity to that second piece that I talked about on the market regulatory side, where across states you're seeing mandates from California, a mandate in their state budget to support long duration energy storage projects. In New York, there's support for long duration energy storage projects. At the ISO level, I think we've seen across ISO New England, PJM, and the Southwest Power Pool, there's all different pieces of rulemaking, legislation, et cetera, on what is the value of energy storage and long duration energy storage and how might that fit within the system. So I think what we've started to see since this report came out over the past several months is that kind of activity, both on that technology demonstration side as well as on the market reform side. And so our goal is just to keep, pushing on that and trying to accelerate that adoption.
Okay, and all those projects that you mentioned, those are all interday and multi-day uh, goal projects. So it's more complicated and more early days for the technology than just stacking up a bunch of Powerwall batteries. I just want to make that clear for our listeners that's why the Department of Energy is pushing on this commercialization and trying to get these projects on the ground and serving different people to see exactly which ones can meet the bill for interday and multi-day storage. That's all the time we have for today, Stephen. So Stephen Hendrickson, head of market analysis in the DOE Office of Technology Transitions. Thanks so much for explaining how the Biden administration is working to turn the potential of long duration energy storage technologies into commercial products. And as always, I also want to thank our listeners for taking the time to check out the USEA Power Sector Podcast. Don't forget to subscribe, like, and share with everybody you know our quest for energy transition solutions.